Friend, welcome back. This is Golden Thumb. In this video, let's play with a classic programming problem. 1 plus 2 plus 3 plus dot 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 plus 100. Okay, the famous Gauss did that when he was very young, 4 or 5 years old. Okay, so we want to calculate. 1 plus 2 plus 3 plus dot 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 plus something, right? 100, for example. You know the answer, right? We'll introduce a concept like accumulator in programming. So how can we write a for loop, right? To accumulate those numbers, we can print out I starting from 0 to this time let's start from 1 and to 100, right? 100 numbers. We can print out of that. Put I here and run it. But how can we sum up all of them, right? Yeah, you see here. The standard way to do it is creating a variable, right? Sum, and put its original value here. Okay, let's specify the data type explicitly. So now this is like a box containing the partial sum, right? So we can do something like that, equals sum plus I. You see? This is, let's play the computer, right, in our mind. Go through every line of code. So here, we assign 0 to this box, the container of partial sum. Okay, now we'll enter the for loop. So the first I will be 1. Then here, this sum is 0 plus 1, and together is 1. We update this container, this variable sum, with the value, right? 0 plus 1. So now it becomes 1. Now the execution arrives here and it loops back to here and check the next I. Next I is 2, right? So, and enter the for loop body. This one, the latest one, this one is 1 now from the previous iteration. But this time the I is 2. So 1 plus 2 is 3, right? The 3. So we updated the container, the variable, with 3. And 3, now next iteration, I is 2. Is it 2? No, it's a 3. Okay. 3 plus this is 3, 6, right? We can print out the current sum here. Current sum, right? Using that sum. Yeah. Oh, we can show I, right, equals I here, like that. Run it. I is 1, I is 2, sum, right? It's accumulating here until this one. Great. Okay, so now let's introduce a new way to do the loop, okay? While loop. So we can compare with the for loop. Let's comment out this one. And we'll write a while loop. Okay, so condition. So we need to define another iterator. I say I start from 1. The condition, we can put a condition like that. I is less than 101, right? So let's use a smaller number to get the feeling of the while loop. Okay, so we can print out the I, right? I equals I, like that. But if we run it, this will be a non-stop, right, loop. So while this is true, it will loop like that, right? Like that. It will loop and print out I equals 1. Yeah, let's give it a try. Hopefully it might crash. Oh, okay, let's stop it. Yeah. It will, oh, okay, it's frozen. Yeah, that's bad. So we need to do something like that. I equals I plus 1. We increase the 1. We maintain the iterator I by ourselves. Okay. Now this time, every time when we increase the I, so eventually it will go beyond 5. Then it will stop and skip this body and go to the end. Run it. Yeah, it starts from 1. Okay, now let's do the yeah, so that's sum up. Yep, do the same logic, right? Sum equals sum plus I, right? Like that. So we still can print out. We can copy this one and put it at the beginning here. Okay, so run it. Oh, sorry, this is not 1. It should be I, right? Yeah, it works. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Okay, now if we change this one to 101, right, we'll get the same answer. 5050. That's great. So while loop, right, it does the same functionality of the for loop, but in a different way. There's a shortcut for this one and that one. Oh, okay. So that's, yeah. So this one can be shortened using the plus equal operator. Okay, that's the same. Let's run it. This is exactly same as sum equals sum plus 1, but shorter, right? Because we don't need to duplicate this token. Okay, now of course we can do this one, right, the same way. Plus equal 1. So we increase, right? You can think of like increase I by 1. In other programming languages we can do I plus plus. I'm not sure if it works here. No, Swift doesn't support this syntax, so let's keep it like that. Okay, so that's the new way to do the looping, right? While loop. So this condition, so make sure never introduce like infinite loop. Okay, so we have to maintain something, so it will end somewhere, otherwise we'll introduce, right, a non-stop infinite looping to burn our computer. Just kidding. Run again. Yeah, so that's it for this video. Thank you for watching. See you next time.